Hi, and welcome back. We're section 1.5. We're going to talk about using a problem-solving plan to solve word problems. Actually, if you went to EFR, this is something that you probably would have been well taught to do in Chapter 6 of the old Chicago Math book. They had a whole chapter on what we're going to talk about here. So I know you've had some practice on this, but this is probably one of the tougher parts of algebra, is having to read a problem out of the book, write your own equation for it, and solve it successfully. And that's something that we struggle on, and that's why we're devoting time right now to working on this. I think sometimes some of us get frustrated because it doesn't come easy. I got some good news for you in a way. This might sound weird, but if it's not easy for you, that's normal. Okay, don't think of yourself as, well, I'm dumb, this is not easy. No, you're not dumb. I struggled with this too. Many people struggle with writing out a problem from words. Okay, so again, we'll spend a lot of time on that this year. There's some basic things though, and some of these might seem obvious, but they're not based on how we attempt to do these problems sometimes. When you're solving story problems, first make sure you read the problem carefully, identify the facts that are given, and identify what you're trying to find. I've had so many times I'll have people come back to my desk and I don't get this. And okay, well, what are you being asked to find? And the person's like, well, I don't know. And I'm thinking, well, did you read the problem carefully? Okay, if you read the problem carefully, and you can all read, you can find what are you trying to find, and then you identify what do you know. Next, make a plan. Try writing an equation using a variable which can help you solve the problem. The book doesn't say this, but I'm going to. I think it is incredibly helpful to draw a picture. When you're making a plan, if you draw a little picture of what's going on, at least for me, that's many times helped me figure out something that I wouldn't have got otherwise. Next, solve the problem. Carry out your equation and your plan and work it out. And then the final thing, and this kind of can get frustrating to me too a little bit in a good way. When I say frustrated, not mad, but just like, okay, what are we thinking here? You got to think about your answer. Does it make sense? Is it reasonable? I remember having a quiz a few years ago, and it was about a guy, and I had him jogging, and I think the answer was, or I was asking my students, how fast is this person jogging? And I think the correct answer was 5 miles per hour. Okay, 5 miles per hour, that's a trot. Okay, it's not very fast. And I had people turning in on their quiz that this guy was jogging 40 miles per hour. So when I passed back the quiz, I'm like, okay, think about this, people. 40-mile-per-hour jog would be like going down Main Street in Frankenmuth and you're passing cars because the speed limit's only 30. You are jogging faster than the speed limit, okay? It doesn't make any sense, and yet people put it on their paper and didn't even think about it, okay? So I think that's a hard one, too. We're so used to using calculators and just plugging in stuff, whatever the calculator says is the answer. You have to stop and ask, does that seem like it's reasonable? In that case, 40-mile-per-hour jog, not reasonable. We're making a mistake somewhere, okay? There are a few formulas they're going to emphasize to you in this section, and these are things that you should at least be familiar with. I don't know that I'm going to make you memorize these, but you'll be asked to use these at times during the year. Converting Fahrenheit to Celsius temperature. I'll be honest, as a teacher, I kind of know that one. If you walked up to me in the middle of summer and asked me what it is, I might be able to figure it out. But that's one I kind of know. This one I'm pretty decent at. Interest equals principal times rate times time. That's a pretty basic one. Distance traveled, I think that's one you should know. Distance always equals rate times time. And this is a good one because most of you, I think, in your life, if you're thinking, when am I ever going to use math? Why is it important? Well, there isn't one person in this room or watching this video that doesn't like having money. Well, this is one you have to know. Profit is always equal to income minus expenses. Your income, what you bring in, better be more than your expenses, or you don't have a profit. Okay, a simple example, you mow lawns and you make 20 bucks and then you go to the store and spend 50. 20 minus 50, you're in the whole 30 bucks. That's a bad situation. You need to be making more than you spend. Okay, profit equals income minus expenses. Let's do a problem together from the homework just to give you an example that we can look at. And why don't we turn to number 32, and let's go, or I'm sorry, page 32. Let's go to page 32, and let's look at question 18. Okay, I think that's a good one. It's not overly easy. Well, let's read it first. Thick crust pizza requires about 1,500 ounces of dough per square inch of surface area. You have two rectangular pans, one that's 16 inches long and 14 inches wide, and one that's 15 and a half inches long and 10 inches wide. Okay, so here's the question. How much more dough do you need to make a thick crust pizza in the larger pan than the smaller one? Maybe I should write that out. That's the question. How much more dough is needed for the larger pan? That's what I'm trying to figure out right now. Okay? Well, I think this would be a good problem. I'm going to draw a little picture here, and I'm not any artist, and you don't have to be either. We're not talking about artwork. We're talking about something that can help us answer this. Well, I'm going to call this my large pan. I'll do like a deep dish more square pizza, and it's got to be rectangular. It's 16, what did they say, 16 by 14. So here's a 16 by 14 inch pan. Okay, well, that's definitely the larger of the two. And the smaller pan is 15 and a half by 10. So I'll try to make this look a little smaller. Again, this is not about being an artist. It's just about having a picture we can look at. Okay, so here's 10 inches and 15 and a half. Okay, and we know one other important fact. There's 1,500 ounces of dough per square inch. Oops, I'm running out of room here on my board. There we go, square inches. Okay, so I need to figure out how much more dough is in this pan than this one. Okay, well, here's the first key thing. If there's 1,500 ounces of dough per square inch, now remember a square inch means a little piece of pizza that's 1 inch long and 1 inch wide. Well, I have a whole lot more. I got several 1 by 1 inch pieces in here. Well, it'd be easy to figure out how many square inches are in this pizza. All I got to do is take 16 times 14 to find out how many square inches I have. So let me do that real quick. Grab my calculator. Got to go to my desk and grab it real quick. 16 by 14. Actually, I ought to be able to do that in my head. That'd be 160 and 64. That should be, what, 224? Let me double check my math. 16 times 14. And, hold on here, 16 by 14. 224. Okay, so I do have that. So this pan has 224 square inches in it. So in other words, there's 224 of these little 1 inch by 1 inch squares in this pan, and each one of these have 1,500 ounces of dough. So to find out how much dough is in this pan, I got to take the 224 square inches, and I have to multiply that by every one of these has 1,500 ounces of dough. And that would give me, let's multiply that out by 1,500. Okay, so this pan has 33.6 ounces of dough. So I'll write that in here, 33.6 ounces. Okay, I haven't answered the question yet. The question is how much more dough is needed for this pan than this pan? Well, I got to figure out how much dough is in this pan. So I got to go through the same process. Okay, every square inch of dough or every square inch of pizza, I should say, has this much dough. Well, how many square inches are in this pan? Well, to find out, it's pretty easy. I just got to take 15.5 times 10. That's fairly easy to do, 155. So there's 155 square inches of dough in this pan, and every one of these has 1,500 ounces of dough. So let's figure that out. I have 155 square inches of dough in the pan, and every one has 1,500 ounces in it. So that's a pretty simple calculation, 155 times 0.15, and I'm getting 23.25. That's how much dough is in this pan. Okay, now I still haven't answered the question. The question is, how much more dough is in this pan than that one? Well, what would I have to do to figure out how much more this number is than that one? Well, how much more? That's a subtraction. So I'm going to take 33.6 ounces in the bigger pan. I'll take away the 23.25 in the smaller pan. And let's get that 33.6 minus 23.25. And it looks like I have 10. There's 10.35 more ounces of dough in this larger pan than in the smaller pan. Okay? So I used all the rules, I would say, that we talked about here. Let me go back. I read the problem carefully. I made a plan, drew a picture. I solved it. Thinking about my answer, this might be a little bit tough to think about. It seems reasonable. I'm looking at my math. I'm not seeing anything obvious that's out of line here. You know, 10 ounces of dough. Now remember, 16 ounces is a pound. So there's a little bit less than a pound more of dough in here. That seems reasonable. Like if I would have had an answer of, let's say, 400 ounces, and you think there's 16 ounces in a pound, I wouldn't have like 50 pounds more dough in here than there. So that would be really ridiculous. So I think that seems reasonable. All right? So hopefully that gets us going again. If you have questions, bring them to me in class, and we can go through those together.